Okay, this would be section 7.5, and it is called Solving Equations. Involving exponents, which I suppose would make sense since this is a chapter about exponentials. So I just want to remind you of something, and then we're going to do a few examples. Just as a quick review, if you remember, we have learned that when we multiply powers of the same base, what we do is add the exponents. We learned that when we divide powers with the same base, we subtract exponents. And we learned that when we have a power and we raise it to another power, we multiply exponents. So basically, what I'm going to do in this section, or what we're going to do, is use this in particular, because this information allows us to do some maneuvering and to be able to solve an equation. So, using the power of a power, I hope that you would agree with me that if we have something raised to a power, and then we raise that to the 1 over a power, and the power I'm calling it here is a, and we raise that to the 1 over a power, then by the power of the power rule, it's a fact then that x would then be a times 1, a raised to the a times 1 over a. You could think of that as a over 1 if you want, which ultimately equals x to the first power, because this is an a over 1 times 1 over a. They're reciprocals, they multiply out to be 1, also known as just good old x. So when we solve equations, we always ultimately want to solve for x, or whatever the variable is. So this technique at times may allow us to free x from being in a situation where it is being raised to a power. For the same reason, if for some reason I had some kind of an x situation raised to the 1 over a power, if I were to raise that to the a power, then I would have x to the 1 over a times a. You can think of that as a over 1 if you want, which really is x to the first power, which also would be x. So these are two different situations, one where we just have an integer exponent, and this is a fractional exponent. So let's try applying this to a couple examples. So here's the first example. If we are asked to solve x to the 2/3 equal to 25. When we see that 2/3, one way to get this to actually just say x would be to say, well, I'm going to take that x to the 2/3 and I'm going to raise that to the 3/2. And so I can come over here, and the problem with doing this is the only way I can keep an equal sign here is I also need to do the exact same thing on the other side, and then I keep my equation so everything is straight in the equation. And so from what we just saw, if I have x to the 2/3 raised to the 3/2, that really is x to the 2/3 times 3/2. And this over here, 25 to the 3/2, if you wanted, you could just throw it in your calculator, but just as another little review, remember the whole concept, power, and this guy down here is root. And I'm going to just do this without having to think too much. So for me, it's easier for me to think of the square root of 25 raised to the 3rd power. So then in the end I have x to the first power, 2/3 times 3/2 is 1, is equal to square root of 25, which is 5, to the 3rd power, which then would be equal to 125. And sure enough, if I were to go back and check that, 125 to the 2/3 power, another way to think about that, just to continue to review this a little, the power root concept, is it's easier for me to think to myself, well, what is the 3rd root of 125? And if I square that, do I get 25? Well, the 3rd root of 125 is 5, because 5 times 5 is 25, and 25 times 5 is 125. And if I take 5 and I square it, sure enough, I do get that 25. So there's one example. I'll give you another example. Given 2a to the negative 3 minus 1 equals 15. If if you were asked to solve for A. And one thing I want to remind you as you're watching these videos is if you want, you could just stop the video, try it on your own, and then turn it back on and see if you get to the same place, if you feel like you're starting to understand it. Okay, similar to a lot of the problems that we have done in this class, whenever we're solving for something, so in this case I need to get this A by itself, usually what we need to do before we do any of the fancy maneuvering that we're learning here is get it alone. So I'm going to do that first. So first thing I'm going to do is get this 1 out of here. So now I have 2a to the negative 3 equals 15 plus 1, which is 16. And next I'm going to get this 2 out of here. So I have a to the negative 3 is equal to 8. So now using the same thought process, really what I want to do, and what the thing I'm thinking about here is what can I raise a to the negative 3 to that when I take negative 3 times the number will produce a 1. And so I need the reciprocal, but since this is a negative 3, I need to use negative 1/3. And I'm going to come over here and do the exact same thing. So now over here I have a, because negative 3 times negative 1/3 is 1, is equal to. Now, there's different ways. Once again, if you just throw that in your calculator, and your calc would be happy to find the answer to that for you. But just to practice, if you remember, everything we look at really is a fraction. So if I want to try to think this through and get rid of that negative exponent, I could take that 8 to the negative 1/3 and just ship it to the other side of the line. So it really is 1 over 8 to the 1/3, which really is equal to 1 over the cubed root of 8, which I think you could probably figure that out with a calc. The question is, what times itself 3 times gives me 8? And that would be 2. So the answer to this one is 1/2. Okay, one more. I think you hopefully will find that these problems are not too bad once you understand the process. So, given 2 cubed root x to the 5th plus 1 equals 487. And the directions would be solve for x. Solve for x. So, in this case, once again, I'm going to get this by itself. Now, this is currently not in a situation where I have an exponent, but for right now, I'm just going to leave it as it is. So I'm going to go ahead, I'm going to subtract 1 from both sides. So now I have 2 cube root x to the 5th equals 486. And I'm going to go ahead and divide this 2 out of here. And so now I have 486 divided by 2, which is 243. Now, there is actually a couple different approaches at this point. One option I could do is I could say, well, if this is a cube root, if I want to try to free that x to the 5th, I could raise it to the 3rd power, similar to when we have a square root, we square it. But since we're sort of thinking about exponents, I'm going to kind of review this whole concept of power root. So if I want to get this out of radical form, then I just say to myself, oh, I can do that. This is the power. Power goes on top. This is the root. Just like tree roots, it goes on the bottom. And now I'm in the position to do exactly what I've done on every other problem. And that is I'm going to raise 5x to the 5/3 to its reciprocal, which is 3/5, which means I have to come over here and do the exact same thing. So I get x is equal to, now once again, if you wanted, you could just throw that in your calc, but for the sake of trying to think this out a little bit, if I want to try to do it without my calc, I'm going to write it like this, because this would be the 5th root of 245 cubed. And so the 5th root of 245 is actually the number 3. And when I take 3 and I cube it, I end up with 27. So there you have it. This is solving equations involving exponents. So your next move should be to go to mathexcelforschools.com and do the quiz.